Hello everyone. Today, we're going to embark on an exciting live project where we'll explore how to implement prompt engineering techniques using the Mistral AI API. We'll walk through code examples step by step, explaining each line in detail. By the end of this session, you'll have a solid understanding of how to leverage prompt engineering to get the best out of AI models for various tasks such as text summarization, question answering, text classification, and more. Let's begin by setting up our environment. We'll ensure that all necessary libraries are installed and properly configured. Here, we're using the pip package manager to install or upgrade two essential libraries, requests. This library allows us to send HTTP requests to interact with web services, such as the Mistral AI API, Python .env. This library helps us manage environment variables by loading them from a.env file, which is useful for securely storing sensitive information like API keys. The exclamation mark is used in Collab notebooks to execute shell commands directly from the notebook. Next, we're importing the necessary Python modules. OS provides functions for interacting with the operating system, including accessing environment variables. Requests, for making HTTP requests. Load .env from .env, to load environment variables from a.env file into our application. GetPass allows us to securely prompt the user for sensitive input, such as an API key, without echoing it on the screen. This line loads environment variables from a.env file located in the same directory. It's a best practice to store sensitive information like API keys in environment variables rather than hard-coding them into your script. Here, we're attempting to retrieve the Mistral API key from the environment variables using os.environ.get function. If the API key isn't found, that is API key is none, we prompt the user to enter it manually using getPass.getPass function. This function ensures that the input is not displayed on the screen, keeping it secure. Now that our environment is set up, we'll define two key functions that we'll use throughout our project: set Mistral params, to configure the parameters for our API requests. Get completion, to send requests to the Mistral AI API and retrieve responses. Let's break down this function. We're defining a function called set Mistral params that accepts several optional parameters. Model specifies which Mistral AI model to use. Default model is Mistral small latest. Temperature controls the randomness of the output. Values range from 0 to 1. Lower values make the output more deterministic. Top P controls the nucleus sampling. It considers the tokens with the top cumulative probability P. Max tokens, the maximum number of tokens to generate in the response. Min tokens, the minimum number of tokens to generate in the response. Stream, if set to true, the API will stream the response. Stop, a string or list of strings where the API should stop generating further tokens. Random seed, an integer value to make the results reproducible. Safe prompt, if true, applies safety filters to the prompt. Docstring provides a brief description of what the function does. We assemble all the parameters into a dictionary called Mistral params. The function returns the Mistral params dictionary, which we'll use when making API calls. Getting completion from the Mistral AI API. Let's go through this function step by step. Defines get completion with arguments API key, params, and messages. API endpoint URL sets the URL to the endpoint for chat completions. If the API endpoint changes, we need to update this URL accordingly. Headers prepares the HTTP headers. Authorization uses a bearer token for authentication with the API key. Content type indicates that we're sending JSON data. Building the payload. Data equals params.copy function makes a copy of the parameters dictionary to avoid altering the original. Data messages equals messages adds the messages to the payload. Removing none values cleans up the payload by removing any keys where the value is none, which prevents sending unnecessary data to the API. Checks if the response status code is not 200, OK. If it's not, it raises an exception with the status code and error message. Return response.json function parses the JSON response from the API and returns it. Now that we have our functions ready, let's dive into implementing various prompt engineering techniques through practical examples. We'll cover tasks like text summarization, question answering, text classification, and more. Here, we're calling our setMistralParams function to set the parameters for our API request. We're setting the temperature to 0.7 to allow for some creativity in the response while maintaining coherence. Here, we're providing a paragraph about antibiotics. We then instruct the model, explain the above in one sentence. This prompt asks the model to summarize the given text into a single sentence. We'll start by using the Mistral AI API for simple text completion. This involves providing a short phrase as a prompt and having the model generate the rest. In this example, we set the default parameters using setMistralParams function and provide a prompt, the sky is. The Mistral AI model will complete the sentence. We use the getCompletion function to send the request to the API and then print the assistance response. This illustrates how even a simple prompt can generate meaningful text. Now, let's move on to text summarization, where the model is tasked with condensing a longer piece of text into a single sentence. In this case, we ask the model to summarize a paragraph about antibiotics into one sentence. We adjust the temperature to 0.7, allowing for some creativity in the output while maintaining coherence. The AI processes the request and returns a concise summary, which we then print. Next, we will use prompt engineering for a question answering task. The goal is to provide the model with a context and a specific question, instructing it to keep the answer short and concise. In this example, we provide the model with a paragraph of context about teplizumab and ask a specific question regarding the source of OKT3. By including the instruction to respond with unsure about answer, if uncertain, we guide the model to avoid making assumptions. This showcases how structured prompts can improve the quality of the response. Now, let's explore text classification, where we'll have the model determine the sentiment of a given sentence. In this example, the model is asked to classify the sentiment of the sentence, "I think the food was okay." Based on this prompt, the AI will categorize the sentiment as neutral, negative, or positive. This simple classification task shows how prompt engineering can be applied to determine the emotional tone of text. Next, we'll explore a role-playing scenario, where the AI takes on the persona of a technical research assistant. Here, the AI is instructed to take on a specific tone, technical and scientific, while responding to a user's questions about black holes. Role-playing prompts like this allow us to tailor the AI's responses to meet specific requirements or user expectations. Next, we will demonstrate the model's ability to generate code. By providing a description of the task, we can prompt the model to write the corresponding code. In this task, we provide a detailed description of two database tables and ask the model to generate a MySQL query that retrieves all students in the computer science department. The model uses this prompt to understand the structure of the tables and generate the appropriate SQL query. Next, we will demonstrate how the model can perform reasoning tasks by breaking down problems into clear steps. This approach encourages the AI to think through a problem methodically. In this example, we ask the model to solve a problem involving odd numbers. By instructing it to break down the steps, we guide the AI through the reasoning process, from identifying the odd numbers to calculating their sum and explaining the result. Here, we provide a structured prompt outlining specific steps for the model to follow. This clarity helps improve the quality of the AI's response by ensuring it adheres to a logical sequence when solving the problem. In this few-shot prompting example, we provide several cases along with their answers, which helps the model learn the underlying patterns. The final question asks the model to determine the answer based on previous examples, showcasing its ability to generalize from prior knowledge. In this scenario, we provide a previous example that details the reasoning process. The model is expected to follow a similar approach for the new problem, which demonstrates how structured reasoning can enhance the output quality. In this zero-shot prompting scenario, we ask the model to think through the problem step by step without providing any examples. This encourages the AI to engage in a reasoning process to arrive at the correct answer, showcasing its ability to analyze information independently. In this session, we've thoroughly examined various applications of prompt engineering with Mistral AI. We began with text completion, progressed through summarization, question answering, sentiment classification, and explored the model's capabilities in generating code and reasoning. By strategically crafting our prompts, we can guide the AI's output toward greater accuracy, relevance, and clarity, illustrating the significant impact of prompt engineering in the realm of generative artificial intelligence.